Hi student, hope that you are doing well at home. Let's carry on with our lesson today. We are moving on to applying our learning, what we have learned last week onto today's lesson involving multiplication with 3-digit numbers with 2-digit numbers. So in terms of concept, it's almost identical. So let's have a very quick review on what we are doing. So first and foremost, for us to be able to multiply the numbers accurately. So first and foremost, we will need to multiply numbers involving the ones area, which is here. So 4 times 3 is 12. And then after that, 3 times 3 is 9. 9 plus 1 is 0, is 10, sorry. And then 2 times 3 is 6, 6 plus 1 is 7. Moving on to the tens. So before we do that, we actually got to add a 0 here. I'm sure most of you remember this. 4 times 2 is 8, 3 times 2 is 6, and 2 times 2 is 4. And the end result is 2 here, 8 here, 13 here, and you get 5 here. So the answer is 5,382 as the answer. Moving on to the next question. Okay, same thing, some revision. So 4 times 2 is 8, we start from the ones. And 2 times 2 is 4. 1 times 2 is 2. And before we do anything, always add 0 first before we move on to the tens. 4 times 7 is 28. You bring the 2 here. 2 times 7 is 14. 14 plus 2 is 16 plus 1. 1 times 7 is 7. 7 plus 1 is 8. 8, 12, 9, 8. Answer is 8,928 as the answer. Before I show you the solution for the third one, I'll request for you to pause the video and give it a try on your own. Okay, let's carry on. And you can verify whether your answer is correct. 4 times 5 is 20. 3 times 5 is 15. 15 plus 2 is 17. 2 times 5 is 10. 10 plus 1 is 11. 4 times 2 is 8. 3 times 2 is 6. 2 times 2 is 4. So it's 0, 5 here, 8 here, 5 here. So the answer is 5,850 as the final answer. Hope most of you have actually gotten this question correct. Moving on to page 82 in your student book. The first part for this exercise is still a 3-digit multiplied by 2-digit, so I'm not going to touch on it, but instead I will touch a little bit on this term commutative, which is stated in the book. So the mathematical meaning of commutative is when you swap numbers around in the operation, you still get the same answer when you add and multiply. So look at this example here, like 3 times 4. Do you agree that it's the same as 4 times 3? Both answers will be 12, isn't it? Moving on, just like addition, 5 plus 8 is the same as 8 plus 5, both giving you the answer 13. But this is not very commutative law, is not applicable for other operations, like for example, division and subtraction. 20 divided by 4 will not get you 4 divided by 20. You don't get the same answer. And likewise, 20 minus 4 is not the same as 4 minus 20. Therefore, you must remember that commutative rule is only applicable for multiplication and addition. Bear that in mind. Okay, I repeat that again. Commutative law is only applicable for multiplication and addition. And last part of the question requires us to actually simplify the operation because I believe the book requires you to work out the solution mentally. So therefore, I've actually written down some examples for you to see for yourself how you can simplify the mental process with a sum of 80 times 20 times 18 times 5. So we can actually simplify 20 times 5 because 20 times 5 will give us a nice number, 100. So 100 times 18, we can easily work it out mentally to get you 1,800 as the answer. Likewise, for the next question, 2 times 10 times 13. Some of you will say, oh, Mr. Leong, 2 times 10 is 20, 20 times 13. Oh, these two numbers, when I multiply together, is actually not too difficult to work out mentally too. But my advice is, if there are easier method, why don't you use the easier method? So instead of doing 2 times 10, you can easily multiply 2 with 13, which give you 26. 26 times 10, you actually get 260. Isn't that easier? So that's actually the end of my lesson for today. And my request for all of you to complete page 68 and 82 in your student book. Okay, thank you for attending the lesson. Feel free to drop me a note on forum if you have any difficulty. Bye.